Welcome back to OwlsPrep. In topic 1.1, we learned to describe whether a function's output rises or falls. Today, topic 1.2, rates of change, where we ask not just whether it changes, but how fast. Think about a road trip. You drive 120 miles in 2 hours. On average, that's 60 miles per hour, a rate of change, distance changing with time. You might have gone faster or slower along the way, but the average rate captures the overall change. That's what this topic is about. The average rate of change of a function over an interval is the change in output divided by the change in input. For a function f from a to b, that's f of b minus f of a over b minus a. It's the single constant rate that would give the same total change, and on a graph, it's the slope of the line joining the two endpoints. Say f of x equals x squared. What's the average rate of change from x equals 1 to x equals 4? F of 4 is 16, and f of 1 is 1. So it's 16 minus 1 over 4 minus 1. That's 15 over 3, which equals 5. Over that interval, the output rises 5 units for every 1 unit of input, on average. What about the rate at a single point? In Precalculus, we don't use calculus for this. Instead, we approximate. We take the average rate of change over a small interval around the point. The smaller the interval, the closer the estimate, but it stays an approximation built entirely from average rates. And to compare 2 points, we just estimate the rate at each. The point where the graph is steeper has the greater rate of change. The sign of the rate tells you the direction. A positive rate of change means the two quantities move together. As input increases, output increases. A negative rate means they move oppositely. As input increases, output decreases. And the bigger the size of the rate, the faster that change happens. So topic 1.2. The average rate of change is the change in output over the change in input. The rate at a point is approximated by averages over small intervals, and the sign of the rate tells you which way the quantities move together. Next, in topic 1.3, we'll see what these rates look like for linear and quadratic functions. See you there.